So as I mentioned earlier, today's presentations are going to focus on leveraging technology in goods movement. And as I mentioned before, Anton Shingarev from Avride was unable to join us today, but our final speaker is going to be helping to fill in, so we appreciate that. Like I said, we're going to hold questions till the end. Jacob will be monitoring the chat box. And and I understand our speakers are actually on the West Coast in California, so we thank you for joining us. It's great that we have these virtual meetings now. So our first speaker is Matt Soul. Is that correct pronunciation?
Very close. It's Matt Soul.
Matt Soul, the founder and CEO of Parallel Systems, a company developing autonomous battery electric rail vehicles. Parallel's technology enables railroads to expand market share by improving service quality, flexibility, and reach. The system works alongside traditional trains, complements existing operations, and integrates with railroad physical and digital infrastructure. Matt has more than 20 years of experience developing advanced technologies within established industries and aerospace. He spent 13 years at SpaceX in various roles, including leading teams in the development and certification of the world's first autonomous flight termination system, hazard analysis and risk mitigation for manned spacecraft, and Air Force certification of reusable rockets. Matt has also worked at Northrop Grumman, Lockheed Martin, and Moog. So we actually have a rocket scientist with us at this meeting. I don't think we ever had that before. Our final speaker is Daniel Smith, a principal with the Tioga Group. Daniel is a founder of that group with more than 45 years of consulting experience in freight transportation strategy, policy, and planning, with particular emphasis on marine, truck, rail, and intermodal transportation. His major clients have included America's largest ports, federal and regional transportation agencies, railroads, leasing companies, and industry associations. He previously worked for Mercer Management Consultings and Manalytics, Inc. So, Matt, I'm going to turn it over to you to get us started. Thank you.
Great, thank you. So, good afternoon, everyone. It's a pleasure to be here and to talk to you about Parallel. So, as you all just heard, we are a technology company that is developing autonomous battery electric vehicles with a very important mission of increasing the use of freight rail for all the public benefits that come with using more energy efficient and safe means of transportation. Next slide, please. So we are based in Los Angeles, and this has really global applicability. We're very focused here on the US, but the way we are pursuing this mission is to focus on the barriers that prevent shippers from using rail more so than they do today. We have a very big difference in market size between trucking and freight rail. We have a nearly $1 trillion surface freight transportation industry completely dominated by trucking, and trucking is an absolutely very important and vital technology, but there's a big opportunity for freight rail to play a bigger role. And what those barriers are for shippers are what we call service quality. So it's not about necessarily raw speed, it's about being consistent, about being regular. And most importantly, we want to solve for lowest cost. This is a very relevant issue always in terms of moving goods, but recently there's been so much focus on increased cost of goods for consumers, and one of the ways that we can get things under control is to be able to reduce the cost of transportation, and rail is very equipped to serve that because of a very straightforward operational design domain, as well as a very energy efficient means of transportation. Next slide. So one of the big advantages of deploying both autonomous as well as electrification to rail is that, number one, you have a centrally managed network. And so this gives us an advantage in terms of deploying AV technology, because our first level of safety is actually integrating into a railroad's train control system. So we're requesting unique movement authority, and we're not going to be encountering other freight trains through that integration. Our perception system is then working within that movement authority to evaluate, is their path of motion free from hazards and obstacles? And we're not having to judge the actions of other trains on the network. What we are looking for is safety at grade crossings, any obstacles that may be across the tracks, washed out ballast, anything that would be deemed a hazard for moving forward. On the electrification side, rail is very energy efficient. You have big advantages of low rolling resistance because of steel wheels on rail. And believe it or not, it's more aerodynamic. Trucks individually experience drag, trains bring that freight together, and you realize aerodynamic benefits of having a bluff body. And so this is why rail really enjoys using so much less energy. And by comparison, Tesla's semi-electric truck has about 500 miles of range with a megawatt-hour battery. We only need a 250 kilowatt-hour battery for that same utility. The other advantage of rail in executing on this is that the infrastructure is really well set up to carry lots of weight. Nearly each axle of a rail car can carry the entire weight of a Class 8 truck. So it alleviates us from the need for a high specific energy density battery chemistry. So we're leveraging lithium iron phosphate batteries. Any technology that's really suited for grid energy storage is going to be a good fit here. So you're getting low cost, you're getting long cycle life, and you're not as concerned about what the ultimate weight of that is. And lastly, the third pillar of our electrification advantage here is that because I have a smaller battery, we need a smaller charger. The captive nature of rail allows us to have very predictive utilization of that charging infrastructure, where one of the challenges with truck electrification is where do you put those large chargers? How do you know that you're going to have consistent utilization of them? Next slide. So the technology we're developing, again, is a battery electric autonomous vehicle. There's a lot of unique characteristics about this. Number one is there's no locomotive required. We've integrated the powertrain, sensors, computers, radios all into this platform. Probably the most unique thing, though, is that we do not have a conventional coupler. And that's because one of the opportunities here is to actually dramatically increase endpoint efficiency. That's a big challenge for rail today is you have very efficient mainline operations, but then you require a large footprint, very operationally intensive sorting and switching operations in rail yards that are also where some of the greatest dangers exist for railroad employees is supporting those operations. So we use a bumper, and what we've done is we've packetized this freight, and our software that coordinates these movement authorities, the motion planning, allows us to combine vehicles together in what we call platoons, but allows us to split off, sort on the network, and what would previously take minutes or hours now can take seconds with this approach. But the software we're developing not just exists on the vehicle. We have control software, perception software, but also this software that lives in secure cloud that allows us to integrate in a railroad, provide a layer of abstraction between our more unique characteristics, but what a railroad's back office is used to seeing. So this is part of our technology stack that we provide to railroads. Railroads are our customers here in the US. Next slide. So just drilling down a little bit deeper into the unique nature of this mechanical architecture, no couplers. Why we platoon? We platoon because it is the right way to use network capacity. Now, we don't need to operate at the same scale that conventional rail does, and that's really revealing to what is the most important part of our innovation here is accomplishing truck competitive economics at small scale and not requiring the large batch sizes that trains do today and the large footprints in the rail yards to actually arrange this freight. But we also move together in platoons because it's more energy efficient. This is part of our IP is we have these bumpers and we actually physically share work through that bumper interface. We're mechanically pushing from the rear and we're amortizing the drag that the lead vehicle sees. All these vehicles are the same. Our software will assign the role of a leader to one of these vehicles, and it is the eyes and ears of this platoon. It is assessing, again, those track conditions. Is it safe to proceed? And it will be the one to decide whether or not to take a braking event to respond to a hazard. But we again allow for a lot of flexibility and a lot of sorting efficiency through this configuration. We have a video here shortly that'll actually show a little bit of that. Next slide. And I know Zoom is going to slow down the frame rate here, but this will hopefully give people a little bit of a visual here. So this is our test site in California. This is showing two vehicles, how they come together No one's required to hook up airlines or separate a coupler. You can see the bumper is physically compressing because it's a passive suspension element. And what you're seeing here is the white box is the lead. It's setting the velocity. The yellow box is controlling its tractive effort to maintain a force in that bumper. There's no magnets involved. That's a common question we get. We're physically pushing that bumper. And this is just looking at our perception system. We partner with several railroads, and so we use our sensor package on their locomotives to train our system. We're localizing our path of motion. We're labeling and localizing different objects around that path of motion that define safety behaviors. And then part of our back office solution is to allow people to oversee these operations. You can drill down any serial number, and if you need to, you can disposition exception. Why did this vehicle stop? I'm going to review data. I'm going to put a person in loop to decide if it's appropriate to start again. Or I can support ground operations by manually moving equipment that maybe was not covered by any previously established motion planning. But this is a glimpse into the new workforce that is going to be created by this. There's still people required to build and maintain track, people to load and unload containers, but new jobs being created to actually oversee these operations from the convenience of an office. And we can go next slide here, since we're looping. So a big part of our story is safety. This is a real cornerstone of our priorities as a company. And we look at this very holistically. Number one impact here is the opportunity to improve safety through modal conversion. This means shifting some trucking activity to rail. And when you separate that mode, you realize an immediate improvement to public safety by not having so many trucks sharing the roadway with passenger vehicles. Looking at the safety impacts within the rail environment, though, again, one of the most dangerous jobs in the rail industry is actually being in these rail yards and supporting these switching operations, hooking up airlines, pulling pins to separate couplers, and these shoving movements that have to exist in rail yards create a lot of danger for employees. And by, again, atomizing this freight, allowing software to route these rail cars like they're packets, it does not require people to be in immediate harm's way. They're off to the side, they're overseeing these operations, but they're not physically in that separation plane. We've also been innovating on brakes. We have not really invented a braking system. We're really just deploying approaches to braking that are more in line with how automotive has developed braking technology. So we have adaptive brakes. We are able to modulate the braking force to adapt to the rail conditions, as well as the weight we're carrying. And this allows us to stop dramatically shorter than existing rolling stock today. We also have parking brakes that automatically engage when the vehicle goes to zero velocity. So all very, very big improvements in safety. And then one of the things that I think is very impactful in terms of safety too is we have a multi-sensor perception system that is tirelessly evaluating the conditions of the rail, the safety of moving forward, and coupled with our better braking is giving us a lot of ability to respond to any hazards that may be out there. The last category of safety that's very key to this entire platform is that we have onboard instrumentation and telemetry. We have tremendous insight into the real-time health of our equipment. We are monitoring, for example, our bearing temperatures 30 times a second, as opposed to using wayside cameras that are looking at bearing temperatures every 30 miles when rolling stock rolls by. And our onboard telemetry is monitoring these for being within bounds. If we're out of bounds, if we're out of family, that can be an alert to a back office. If no one responds, the vehicle can automatically stop if there's an unsafe condition detected. We also have accelerometers also looking for unsafe dynamics. So many opportunities to actually acknowledge and respond to equipment that may be out of spec to improve safety in the rail environment. Next slide. So I believe Jacob asked to provide some insight into like how would this benefit the New Jersey region? Obviously, we have one of the biggest container ports in the U.S. in New Jersey, and that creates a tremendous opportunity. to use rail to serve this port. There's local opportunities. We are working with the railroads around ports to connect ports directly to warehouses. This is a big cost reduction, as well as a big opportunity to decongest some of the truck traffic that comes in and out of ports. Many ports we talk to view it as a necessity to increase rail's market share for ports going forward in the future. We cannot just simply keep building bigger and bigger highways to feed volume in and out of these ports through trucks. We have to have rail play a greater role, and we aim to help support them in doing that. But we can also look beyond the immediate port regions into how do we feed containers into the greater southern New England and New York, New Jersey areas, Pennsylvania as well, a lot of warehousing in Pennsylvania. How can we use this platform to increase our connectivity to that region? And again, this is something that is empowering railroads to create a service that is really not very feasible today, works alongside their existing freight rail operations, but is able to be more flexible, to have better service quality, to be more flexible and require a smaller footprint, all again with the benefits of using more energy efficient means of transportation and decongesting highways. Next slide. So where Parallel is at right now is we are doing a pilot in southern Georgia. We had FRA approval to start this pilot back in January, and we are in the late stages of phase 2 of this pilot. This is initially an opportunity to verify and validate our operations and safety controls in a real world environment. It's been incredibly valuable for us as well as our partner railroad, Genesee and Wyoming. And longer term, we look beyond this pilot as an opportunity to again shift trucking activity to rail, stand up inland ports, increase connectivity of different communities to the port, to allow them to be candidates to attract warehousing and other services that exist in the southern Georgia area that support this port. Next slide. And then this is another video, and hopefully it will not be too jerky. This is showing our vehicle. We're just operating one vehicle right now to start. You can see we're plugged into charge there, but we're operating on the general rail system. This is a very big moment for us. It's a lot of work to analyze and document all the safety cases to be able to do this, but we are actively on this rail system and we are demonstrating our technology. And I believe that is it.
Thank you for that. That was very interesting. I know we've got a question here, but I think Jacob, the plan is to move to Daniel, and then we'll do questions. So with that, I'll turn it over to Daniel Smith. Dan.
Sure. Excuse me. We'll give this a try. Is voice level okay?
Sounds good.
Okay. Thanks for the opportunity to talk. What I'm going to discuss today is basically derived from the NCHRP study we finished in 2022, which was published in 2023. This was on the state and local impacts of various kinds of autonomous and automated vehicle technologies with a focus on freight. And I've actually put a link to the study in the chat there. It took me 2 tries, but I did get it in there. So you can get a copy of the study if you like. The toughest chore in putting together these slides is trying to update our knowledge on all the different technologies and developers that are out there. Since I put together this information last week, half of it is probably out of date, but we'll talk more in terms of principles. And working with Jacob, we expanded the scope of this presentation at the last minute, so it may not be as slick as I would like. Next slide. So let's start with the basics. And you've probably all seen variations on these diagrams of the different levels of automation. For the most part, where we're headed is level 4 operation, which is called high automation here, not full automation, not full autonomy. Really, nobody out there is trying to pursue a technology or a vehicle that will operate without human monitoring or potential intervention. As Matt mentioned, there has to be a management system. There has to be the ability to check the status of what's going on, to intervene when needed. And the other thing is, what we've heard developers say is that the incremental cost of trying to go to full automation, really go anywhere without human intervention, they can't see that being justified. So we're really headed for level 4. Next. So there's a lot of expectations around autonomous vehicles and automation in general. The listed benefits on the left, you've probably seen written down in many places, safety, productivity, and so forth. And there are absolutely some benefits to be had there. For trucks, for example, the ability to operate 24/7, you get better utilization of the equipment, you may reduce transit times, etc. The main target, however, for all of these initiatives is labor costs. For trucking, labor is the largest cost. It's not the fuel, it's not the truck, it's the driver. So there's where they're looking to reduce costs. A lot of the potential challenges that are out there are not necessarily technical. Like Parallel, all these developers are working to resolve the technical challenges, and they're all making progress. That's one of the reasons why I say everything may be outdated in a few days. One side on the autonomous vehicles in particular that needs a little more emphasis is the expectations around safety. Two things have not been explored very much. One is the need, how many autonomous trucks do you need to penetrate the fleet before you get the full safety benefits? There are an awful lot of trucks out there. It will take, even if we start tomorrow cranking out autonomous trucks as fast as we can, it's going to take a very long time before we get significant fleet penetration. And there's been very little study on how many vehicles in the vehicle stream on a street need to be autonomous or automated before we get real significant safety benefits. The other shortage of research here is on ADAS. That's the automated driver assistance systems. If you've got a car made since about 2015, you know you may have everything from lane departure detection, adaptable speed control, backup cameras, etc. When we did this study, we really could not find any useful information that compared what's achievable through ADAS systems with the driver in place and what, if any, additional benefits you get for level 4 automation without a driver. So there's some gaps and there's some challenges out there. Let's go to the next, and I have no idea why it thinks that's slide 18. If there is a critical limit, can you go back one? Did we jump 2? Okay, I seem to be missing a slide, but let's go to the next one. This is probably
Automated.
the most critical slide in the whole deck here. And it took us a long time to come to this point where we could really succinctly say what is necessary for really widespread deployment of autonomous vehicles of any kind. And the 4 things together are, first, the operational design domain. You heard Matt mention that. That is sort of the foundation. Where is this vehicle going to operate? What is it going to do there? You know, how far and in what conditions can it operate without intervention? Right now, for example, most of the autonomous trucks pilots are focusing on freeways and rural highways. They're not really trying to navigate city streets. That's a different challenge. So we don't expect everything of these vehicles. We expect them to successfully and safely operate within their operational design domain. They need to deliver private benefits to the operator and to the customers. They need to be worthwhile, whether it's a safety benefit, a cost benefit, or some combination. There need to be private benefits for somebody to build, develop, and operate these vehicles. Infrastructure and regulation needs to be in place. The infrastructure requirements are less than you might think, and we can touch on those. But we have to make sure that whatever infrastructure the vehicle needs is there within the operational design domain, and that you have the legal, insurance, liability, all those other institutional factors that surround transportation have to be in place. And public acceptance. If you are getting pushback from the public, that's going to be reflected by elected officials. That's going to be reflected by regulators. So this needs to be accepted by the public, not thrust upon the public. So let's see how that might work out for some different kinds of vehicles. Next. Okay, sidewalk robots. You have sidewalk robots operating on a test basis in Jersey City. Has anybody in the group here actually used one or been a customer? Not hearing any. Too bad. I would like to hear details. These sidewalk robots are basically very appealing. As you can see, they almost all look a lot alike. They are, in fact, cute. And it's an interesting idea. There are 5, maybe a couple more development projects underway. Avride, which is operating in Jersey City, and Avride, by the way, also is developing autonomous taxis. Starship is the largest and best known, actually a development that came out of Estonia. And Starship robots are operating in a number of cities worldwide. Serve Robotics is the successor to the Postmate robots. It's the one in the upper right. That's operating in a few places, including LA. Segway is providing the technology, etc., for the COCO system, which is also operating in LA. And down in the lower right, that strange looking thing is RoboMart. That's very different than the others. As you can see, it's on the road, not on the sidewalk. And it's essentially an autonomous set of lockers moving around on wheels. So that's kind of a different creature than the others. Some of the early pioneers are now gone. FedEx and Amazon have ended their development programs. An interesting Neuro, which was a little like RoboMart, shifted to really becoming an AI developer rather than a vehicle developer. So they're all basically similar. Most of them will carry the equivalent of maybe 6 pizzas or 1 or 2 bags of groceries. They are all monitored. None of these are truly autonomous to date. And of course, they sometimes have to be rescued or repaired or so forth. There's very little information on the economics or the costs of these things. The Starship operation, I believe, in Wichita State University, they're charging $2.49 for a delivery. So, but there's really no experience with how much these things would cost to use, what the charges would be. Now, as I said, these are not commercial operations yet. They are essentially all venture capital backed. And right now they're consuming money rather than producing it. Serve Robotics, late last year, earlier this year, just did $240 million worth of venture capital funding. Let's go to the next slide. Some limitations and observations here. It's a urban technology. That picture on the right is the street outside my house. I live up and left there, and the circle is where the sidewalk literally ends. So in a lot of suburban and rural, particularly rural settings, there is in fact no sidewalk and no real safe place for these things to operate. The other issue is the ability to do chained trips. Deliveries right now are dominated by the Postal Service, UPS, FedEx, DHL, Amazon. A typical UPS truck may carry 200 to 300 parcels, and it's making basically the same trip every day. So the marginal cost of an additional package delivered by UPS is very, very small because of these chain trips. The suburbs and rural communities are really too dispersed as well. For example, for me, the closest grocery store is a 15-minute round trip. Sidewalk robots operate at basically walking speed, around 3 to 5 miles an hour max. For a robot, a shopping trip for me would be 50 minutes each way. So that's not really a very good trade-off. But that's because I live in an old suburb. We don't know the commercial viability yet. There are some real issues about what happens when you get a large number of robots trying to share sidewalks with pedestrians during rush hours. So the same time you would like to get your dinner delivered is when the sidewalks are going to be busiest. So that has caused problems in some places and will cause issues, because it's one thing to have 1 or 2 robots operating downtown. It's something else entirely when you're trying to dispatch 100 robots from a row of restaurants or from a mall with a shopping center in it. The other thing about, in fact, all these AV things is one of the attractions from the public sector has been the notion that we're going to get data back. That because of the interaction with public infrastructure, whether it's trucks, robots, or drones, that we're going to wind up having data on vehicle movements, which will help us plan and size infrastructure. Not going to happen. None, underline none, of any of the developments are based on any communication or data exchange with the public sector. And there's a reason for that. If you go to a venture capitalist and tell him that your success of your venture depends on interaction with public infrastructure that is not in place yet, he will show you the door. So there's no funding available for developments that depend on the uncertainty of future infrastructure. The other thing is that there's a mix of systems in place for the sidewalk robots. Some use primarily cameras, some basically map the neighborhood and use the map, and many, I think, use some kind of mix. A lot of that's proprietary. So the question becomes, how do you expand out of a mapped neighborhood? And is it worthwhile mapping a neighborhood if there's only 1 or 2 customers out there? So there's a lot of things to be answered. They're working very hard on the technology and they keep making progress. But again, the issues are less technological as fitting it in with existing institutions and so forth. Next slide. Okay, for all of these technologies, we put together these sort of summary slides, and we looked at the scenarios. Where might it be developed in the short term and the long term? And for sidewalk robots, we thought in terms of a limited route scenario. Restaurants or stores that can deliver in their neighborhood using repetitious movements on the same basic neighborhood. So this robot does not have to learn a new set of streets for every trip. They're limited by size, of course, to date. There's only so big you can make a sidewalk robot, which makes it very difficult for them to replace any route-based multi-stop system. And it's going to be a very long technical and institutional reach between operating in the neighborhood of a restaurant and operating throughout a city. So let's go on to trucks. and I hope I'm talking fast enough here. Okay, autonomous trucks. The best known one here is probably Kodiak on the upper left and on the lower right picture. Kodiak, as far as I know, is the only one who has sold trucks to a customer. They've sold 8 autonomous trucks to a Permian Basin mining operation. I don't believe these are operating on public streets. I think they're a closed system in the mine. All of these folks are testing runs on public roads, as I say, primarily freeways and rural highways, with a driver making the in-city driving and operations. They all have safety drivers. So you may not see anybody in the cab, but the Kodiak for lower right, I believe, or maybe it's the Aurora or whatever. They have back seats for the drivers. So there is someone in those cabs when they're operating on city streets. I will also point out, look at the website names. You notice how many AIs there are? The whole industry seems to be pivoting toward AI. And Too Simple, for example, which was doing trucks a while ago, is no longer trucks. They're rebranded as Create AI now. And all of the active ones have quote unquote drivers: Kodiak driver, Aurora driver, Wabi driver, et cetera, et cetera. So they are emphasizing their AI developments with potential applications elsewhere or in somebody else's trucks. And of course, with the AI label, it helps you to raise funds, which is critical. Kodiak lost $274 million last fiscal year. They are going public. So there are limitations now. 1 or 2 of them can start operating at night now, but I don't believe any of them are yet capable of operating consistently and safely in rainy weather. So there's a long ways actually technologically for them to go until they can basically be sent to deliver goods across the country. But again, the technology is improving all the time. They're not really very good for local multi-stop deliveries. Gatik on the upper right, you see it's got a Kroger logo on it. That is intended for last mile deliveries. In other words, say from a distribution center to a retail store. They're not made to serve individual customers. There's nobody to get out of the cab, pull the thing out of the back of the truck, and bring it to your door on a hand truck. That's still going to be the domain of UPS and people like that with human drivers. We can go ahead, next slide, I think. So on the left, again, they're all using safety drivers so far. Everybody hopes to go to that level 4 solution where you can monitor them remotely. Now that does raise an issue. If you're dispatching a truck from Texas to Alabama and the truck breaks down somewhere in between, how do you rescue it? It's going to happen. It happens with ordinary trucks, so it will eventually happen. Autonomous trucks can get flat tires. So there's a question of how you rescue or get a remotely monitored truck back in service. The emphasis, again, is on the line haul labor cost savings. Safety, yes. Productivity, yes, but mostly cost savings. Again, there's no anticipated data swapping between vehicles or between vehicles and the public sector. So I'm sorry to disappoint anybody, but you are not going to get additional data on freight operations. And it's probably multiple decades, in other words, 20 to 30 years before, in fact, we get significant fleet turnover to the point where you would routinely see these things on the road, or we would get the safety improvements from cooperative vehicles, reaction to traffic and things like that. Next slide. Drones look like fun, and it's a very exciting idea. You know, this again, kind of cute, exciting thing comes down and drops off a six-pack on your lawn. Here too, there's half a dozen or so operators in the US. There are more worldwide. There are some that have quit, or in sometimes, again, in the case of a company called Zing, they've really morphed into a tech company rather than a drone company. I'm not sure. Prime Air, which is the arm of Amazon, they suspended operations this month because of some incidents, I believe, in Texas, among which one of their drones collided with a construction crane, which was not good. And UPS Flight Forward is a little hard to track because their more recent stuff is vertical takeoff and landing small piloted planes rather than drones. I would say throughout all of these technologies in the companies, it's kind of hard to understand from public information what they're doing. You go onto the websites and they've got really nice videos, but there's nobody like Matt available at these companies to answer your questions. In general, most of them can carry around 5 pounds or so. That varies. You can see the bigger zipline ones actually lower a module onto the ground. And I'm not sure how much that one can carry, but the typical payload has been somewhere around 5 pounds, going up, particularly the left one, which I believe is Flytex. It's a bigger machine now. So we're talking about maybe a bag of groceries, but it used to be their payload was basically limited to a six-pack. They don't have the capability back. There's a real issue around air traffic control. These things fly at about 300 feet maximum, maybe around 60 miles an hour. That's high enough to be of concern to conventional aircraft. So there is not, and of course, air traffic control is right now and has been an embattled agency essentially. So there's some real questions about how you would integrate a large number of drones in a metropolitan area with conventional air traffic control. The technology, as I said, is improving. FAA has recently approved what's called out-of-sight operations. It used to be that you could only operate a drone within line of sight, which of course makes commercial operation basically impossible. But now some are now licensed to operate out of sight, which is a big step forward. Next. There's a real issue with drones in access. And for that, let's go straight to Newark. If you look at the rooftop of one Newark Center there, that looks pretty good. You've got a big lawn, you've got a parking lot, you've got a flat roof with not too much clutter. But if you go a couple of blocks away to Market and Broad Street with older urban buildings, that does not look like a very hospitable environment for drone landings. Maybe on the far right, we've got a parking lot, but other than that, you've got cluttered rooftops, you've got pitched roofs. I don't think that area would be very hospitable to people trying to do their holiday shopping and have it delivered by a drone to the rooftop. If we go out to the residential areas, it really varies widely. If we go out, I guess it's west to 14th Avenue and 6th Street there, you've got trees. You've got big trees. You've got very small yards, if there's a yard at all, and maybe a driveway or maybe no driveway. And you have power lines, all kinds of power lines, cable lines, phone lines. And the roofs are typically pitched. So there becomes a real question about whether or not you can serve these kinds of neighborhoods in any volume with drones. Maybe no safe, maybe no practical place for them to land and take off. And the little chart up at the top there, which was taken, I think, from the zipline site. Yes, these can go places very fast. They move about 60 miles an hour. And if you can take a straight line from origin to destination, you can certainly beat somebody driving a car. On the other hand, taking that straight line means you have to fly at 60 miles an hour and 300 feet over an awful lot of residences and other buildings. There's some real intrusiveness issues and some noise issues. If you've ever heard a drone, they sound like a tree full of about 1 million angry bees. We get them in our neighborhood because the utility uses them to inspect the power lines. So there's a real compatibility issue there. Next slide. Now, it's very clear that drones have a place in emergency and public service. Some of your agencies are probably already using them for remote inspections and things like that. It's the very best way to look at the underside of a bridge. And yes, public safety agencies have uses for them, emergency shipments, and when nothing else will get something delivered, the drone may be applicable. That transition between emergency public service use and commercial deliveries, no one's really crossed that boundary yet. There aren't any sustainable, commercially successful applications of drones out there. They're all demonstrations, supports, tests, etc. But that's reasonable for where the technology is. Their role is very limited by the size, the ability to access, and their operational design domain. You can't deliver anything of any real size using a drone, not for the kind of ones we're talking about. And then, as I say, there's major issues to be resolved with air traffic control. Last slide, I think. Okay, to summarize all of these things, and I brought this diagram back because I think it's sort of the critical point here for all of them. Right now, what's out there are test and demonstrations. When they say commercialization, for the most part, they mean that somebody is paying to use the technology on a test basis. For the sidewalk robots, you can go through DoorDash, and if it's available in your area, you may be able to get delivery by a sidewalk robot. I haven't been able to try it myself. They don't come to our neighborhood. But that when they say commercialization, they don't mean that they are operating a company which is economically or financially stable and sustainable. They are proceeding without public improvements for autonomous trucks, for example. The main thing they need is good roadway striping. There's an issue in the snow when you can't see the stripes, but if they can, and this is the same for the features in all modern cars, if the cars can see the stripes and if they can identify curbs and so forth, that is the most important thing. That's what lets them navigate. They can get lost if they can't find the stripes and the lines. Technology is moving forward. They're working very hard out there. They're looking for workable commercial niches. And there is this new emphasis on AI. They've been using AI all along, that it has been called different things, and it was not so much in the public attention. For planners, it's a very long time still to what I would call common commercial operations, if they ever occur. The infrastructure needs are going to be minimal because they can't wait for infrastructure and they aren't going to give you any data. So with that, I think I'd be happy to take questions.
All right, that's great. Thank you all, both very much for that. I'm going to turn it over to Jacob to handle the Q&A, but I'm going to take the pleasure of the chair and ask the first question of Matt from Parallel, and that is, with where you are today in your technology, what would you see as the timeline to actually have that deployed in the real world?
It's a great question, Stephen. I'm going to be careful not to project a firm timeline here because a lot of other AV companies have done that in the past and then found out it's taken longer. But we do think because of the strategy we're employing here that this is a shorter timeline than what you're looking at for AV trucks. Again, as Dan has pointed out, some of the challenges there because unique to us, we do have V2V communication. We do have V2X because we're specifically integrating the railroads. But we see this as something that is on the horizon within a couple of years for early deployment. We are doing our pilot with human supervision over all operations. We are doing ride-along with our perception technology as we develop that safety case. But it's a big advantage, right, to have those features and also have this more uniform ODD that Dan has spoke of. And this is this is not going to be the answer for all freight needs, but again, I think there is a big opportunity for modal shift and public benefits that can come with rail playing a bigger role.
All right, thank you. So with that, I'm going to turn it over to Jacob to handle the balance of the Q&A.
All right. I think this one's for Matt as well. So Matt, in order to increase the number of available shippers along a rail line, is to create warehouse sidings which will allow loaded cars to be switched into a network. The cost and timing of switch installation is substantial, and also what federal or state rules apply to personnel to oversee such switching?
Sure. So that's a great, well-informed question. So yes, there is often capital required to add a spur. The good news is that because of the high asset turn of this platform compared to conventional operations, the size of the infrastructure is actually quite a bit smaller than what you'd typically expect. And we are actually in various stages of commercial deployment discussions with some of our customers, nothing I can unfortunately talk about right now, where that CapEx has been factored into the financial pro forma, and it looks very, very good. So it is an expense. I will highlight too that density does matter. I mean, it's something that I heard as a theme with some of the content in Dan's conversation is density matters for a lot of these technologies. So we're not going to make sense for like moving one container to a factory one time a week. Like likely that it's not going to pencil. But there's many, many, many warehouses, transloading facilities that are doing hundreds of containers a week, which is significant, but still substantially below the threshold where it would make sense for rail to serve. And in those cases, we're seeing the CapEx of building a rail spur and switch look very, very attractive. I think the other question is about state and federal regulations. We are treating all the workforce around this technology as still being subjected to the federal work limits. We don't want people to be fatigued. This is an assumption we've been carrying, which seems to be validated by the regulators that we engage with. There are, not to my awareness, any regulations that specify how people do their roles in the job. This is generally entrusted to the railroads to have the operational and safety plans around how personnel perform their jobs. You do have certifications prescribed by on-rail operations, though, that are been more of a forefront for what we've been evaluating how to move forward.
Okay. This next one is for Dan. Dan, was the Insurance Institute for Highway Safety involved in any way in your research?
We haven't seen anything recent. I don't think they have been particularly active, but again, we haven't looked at that for a couple of years, so that's something I would have to follow up on. Insurance is an issue because one of the questions is liability. How is the liability, for example, shared between the operator and the company that may have supplied the software and sensor systems? If an autonomous truck fails or causes an accident, is it because the company did not supervise it correctly, or is it because the manufacturer did not equip it and program it correctly? And there, as some of you may know, there are what are called nuclear verdicts in the trucking industry, where accidents can be, awarded multi-million-dollar settlements that will essentially bankrupt the company. So it's a very big issue. I just don't know that you have made much progress on a resolution.
Thank you. Back to Matt, another rail question. One of the obstacles to starting new rail service is aggregating sufficient market demand to support regular service. Could autonomous rail technology potentially lower the barriers for initiation of a new service? And would irregular service to a smaller market become economically more feasible?
Yeah, that's a great question. So I would maybe modify that question a little bit with not necessarily autonomous rail, but our technology specifically has the advantage of having truck competitive economics at small scale. So, but to the question I think that's really out there is like, does this increase ability to serve smaller markets? Absolutely. That's a big part of what we're working to create here. Conventional rail works when you have large batch sizes, right? You need those large batch sizes to amortize some of the fixed costs that exist with conventional rail operations. And for a railroad to consider opening a greenfield intermodal lane, yes, you absolutely have to have huge volumes. It's a big capital bet for them because if you're building 2 greenfield terminals, those are $200–300 million infrastructure projects at either end. And so you need to have a tremendous amount of volume to justify that. Our advantage is that because we have this unique platform, it's enabled by autonomy. We don't have nearly the same capital thresholds. Like, yes, we do have some sensitivities to density, but not anywhere near where conventional rail is. So it allows a railroad to experiment with new lanes without having to make those big bets. And I think that's a really important enabling characteristic of this.
Thank you. Back to Dan. What is your understanding on the differentiation of rural versus urban drone operations under the FAA's proposed Part 108 waiver program? Are there specific industries that would be applicable to utilizing drones in those various areas?
I'll start by saying that I'm not up to date on the FAA drone operations, so I don't really have a good answer for that. On the specific industries, a couple have popped up. One is interestingly enough, it's the medical testing industry. One of the pilots, and I don't know if it's still going on, was, I believe, in Virginia, where they were moving medical samples between hospitals and testing laboratories using drones, because the drones could cross the bay. And maybe that's an issue for San Francisco and New Jersey as well, where vehicles need to take a roundabout route or use a bridge or something like that. Drones can fly right over the water in a straight line without bothering the residents, as far as I know. So there are some specific applications like that. You would have to have, what you're looking for is something that is high value and which is very time sensitive, or very high time value. And things like medical samples qualify.
Okay. Thank you. Back to Matt. What are expected loaded vehicle weight parameters? Is there a need for 286K? Do you foresee potential passenger rail opportunities for this technology down the road?
Yeah, great question. So our vehicles right now are not handling the fully loaded weight of typical rail cars because we are focused on intermodal as a service here. We're focused on that market share growth. And our next generation vehicle, which we're going to start production of next year, is designed to carry 2 fully loaded 20s, which I believe puts us at a payload weight of about 150–160,000 pounds on top of the vehicle weight itself. So we're coming in a little bit lower than that 285,000 pound gross rail car weight that we typically see out there, because we're not focused on bulk products. However, the most important part of the technology stack we're developing is the electronics, the control systems, the software for train control, integration to railroad's business system, that V to X integration. And this is a technology that could be readily applied to a heavier haul vehicle. It would just be a different mechanical form factor, like heavier duty bearings, different gearing, different motor size. But the core tech stack can be readily adapted to like different weights. I think this absolutely has future passenger rail opportunity. That is not our focus right now. Our focus is moving non-hazardous freight. And then the step up from there would be to move hazardous freight and then ultimately move to something that would be passenger rail if the business case is there.
Right. And another one, how would the movement of freight on the autonomous rail cars be moved off their cars to the destination? Would that be automated as well, or would that be done by the current means?
So there's a portfolio of solutions here, and the commercial discussions we are having with railroads as well as shippers, it ends up getting a little tailored to what their application is. So a lot of our operations right now are a lot of these early operations are assuming conventional lifting technologies, either depending on the density, you could have a gantry crane or you could have a human operated reach stacker, which is just a really heavy duty forklift. There's absolutely a lot of opportunity though to introduce automated lifting technology. And there's a gap in the market that we see personally, but we're focused on executing on this initial vision of getting this autonomous vehicles out there to move intermodal containers, and then we'll look at what are the right opportunities to lower the barriers to using rail by improving the efficiency and reducing the cost of lifting operations. And some of these like automated lifting operations would make sense for like private yards. We've also worked with some shippers on concepts where we're basically bringing back like almost like the boxcar era, where our cars go up to a platform, you drop a steel plate, and then you have a lower capex forklift that is, if it's palletized freight, you're pulling those pallets out directly and rather than lifting a 50-60,000 pound box off of it. So I hope that gives you like an idea of like the different ways we're looking at solving for that.
And I guess a follow-up, you mentioned customer service side benefits. Can you expand upon what those are? In other words, any day time, just-in-time delivery, more frequent branch line service profiles?
Yeah, so at the highest level, the feedback railroads are our customers, but we talk a lot with their customers, which are shippers. And one of the most common themes we hear is, I would love to give rail more freight, but their service quality is too inconsistent, or they just don't have the lane open. Like I don't have the option. So I think Dan touched on like, the driver shortage or the problems of maintaining a driver pool necessary to move all of this freight by truck, right? Because it's 1-to-1 for every unit of freight, you need a driver. A lot of people love the idea of variable capacity, but for many of them, service quality can mean different things. It can mean I need daily service. I need you to be in this window because I need to plan my operations around it. And that's one of the indirect costs of doing business with rail today, is that even if I'm saving money with the rail, but then I have this various service, like maybe it's coming Thursday, maybe it's the following Monday, I don't know. Now I need to have more inventory tied up in transit. I need to have bigger warehouses. So these are indirect costs of doing business with rail today. And so because we are not gated by availability of locomotive, availability of crew, we can respect time slots that have been pre-planned in the network, and whatever cars are loaded, we go into that time slot. And that's one of the ways that we are able to achieve higher levels of service quality, but also rerouting. A lot of refrigerated freight that's time sensitive doesn't go on rail because it's very hard to reroute it if there's an issue with the reefer. So that's enabling capability of this platform, being able to have any freight routed to a new location, because we're not limited to, we've got this big train, we need to get to the yard, and then we can like break stuff up. We can reroute it on the network itself. And of course, railroads generally operate 24/7. But this is, I think what's enabling about this is that we can work around warehouse hours. We can open up more flexibility in service hours because we're not limited by physical presence of employees at the right location. We're really, we're basically creating a level 4 type of autonomy solution that still has people in the loop, but they're remotely supporting these operations. So you have now these support centers that are in office with regular hours, and then as vehicles need support from people, you're patching in those people to those operations, and so you can operate around the clock with more flexibility because you don't have the constraint of having the person physically in the field.
All right. Another one. So currently railroads use a per diem system where cars sit for days to load and unload. Along the lines of delivery issues and timeframes, what do you expect to be the cycle time for parallel vehicles, and how does this affect the cost?
Yeah, so great question. We look at, when we do service designs with our railroads, we're looking at dwell times that are measured in hours rather than days. And one of the other characteristics that's related to this is putting more of the burden of the endpoint operations on the customer, where they get to have more control over this. Like we were talking about rail spurs earlier, we're negotiating several deals where that customer's facility becomes now the yard, and so they're now more in control of their destiny. The vehicles show up. There's going to be an agreement in place that has to be unloaded within a certain amount of time because the railroad cares about their asset efficiency. It's early, but we're seeing a lot of hope around resolving some of these. We're very aware of like these fees stacking up and sometimes not feeling correct because the customer doesn't even have the ability to offload it.
Okay. This next one is for both of you. What safety measures are being done to prevent hacking into the autonomous rail or trucks?
So I can go first there. We are broadly pursuing cybersecurity practices that are current SOC 2 compliance. We are looking at the TSA. I think there's published standards from TSA in terms of like cybersecurity. So it's a very important part of our like overall safety narrative, is making sure that we have encryption. We're getting the right compliance and certifications. We have user authentication as all part of our stack and how we do this.
Ben, do you have
the
any?
On the truck side, remember, actually for all the autonomous freight vehicles, they're all monitored. The trucks all have personnel on board at this moment. I don't know that it's emerged as a significant problem yet. There was a demonstration that was done a few years ago to demonstrate the feasibility of taking control of a vehicle remotely. It was done with a Jeep of all things. But that was done specifically to demonstrate that it was in fact possible. Without knowing the details of the technologies of these things, I think it's safe to assume that the issue is being taken seriously. But again, we're not talking about level 5 autonomy. We're talking about level 4 high automation. And that's a very critical difference.
I'm going to jump in along the same line. So I guess we all heard the AWS services went out, I guess, early this morning and into the morning. Something like that affect the operation of these technologies?
I'm sorry, I
I can
didn't
go.
hear the whole statement.
So Amazon Web Services went down last night, which impacted a lot of different industries and such. Cyber world. So would something like that impact the operation of these technologies?
I suspect it would. I mean, these are basically cloud-based technologies because these vehicles can be very remote. It can be a state or two away. So it pretty much has to be cloud-based. And it would be reasonable for them to have redundancy, but if something as big as Amazon Web Services goes down, that's going to affect a lot of people. And if nothing else, there would be a significant delay. Now, basically, autonomous vehicles of all kinds, including the experimental passenger stuff, if they lose communication, they just stop where they are. Now that becomes an issue if if you know you can't get them off the road and things become jammed. So I think there's a lot of work to be done for any kind of vehicle that's operating in the public realm to handle the conceivable emergencies and disruptions. It's very different where Matt is operating on a closed system.
Yeah, just to add to that, so we do use AWS right now, but and we've not done it, but it is a plan to host a private server at our customer's facility for these services, right? To mitigate some of these issues. And in terms of comms, we have a multi-source WAN, Wi-Fi, multiple LTE carriers, private LTE is an option for us, satellite comms. So that is one of the ways that we are planning and making investments to handle the comms needs as well.
Just a quick follow-up on that, Matt. So you would basically, for a customer, you would be selling them the technology, the vehicles, and the technology to run the vehicles, and then I'm assuming
Yes.
providing some kind of training along the way, or would you be providing staff to go with it? How would that?
So early days we're hands-on, right? Because this is a very new thing. We're very focused and committed to customer success. So we want to be right there to be partners in making sure this gets ramped up successfully. Everything is safe. Everyone understands how to use it. But ultimately, like this is part of the job creation story for the railroads. It's like you're training these workforces how to operate this technology, how to maintain it, service it, and that would be their workforce over time.
And for many, many years now, there's been talk of running these shuttle trains from the port to these kind of large clusters of warehousing. And you mentioned one of them, Matt, is in Eastern Pennsylvania, but we actually have one a little bit closer to home down the turnpike, exit 8A. Does that almost seem like kind of an ideal scenario to roll out this type of technology?
Yeah, absolutely. I mean, we're about like freight rail today serves freight lanes that are large volumes, high density and long distance, like LA to Chicago, but then really struggle with these like less than 500 or less than 1,000-mile lanes or lower density, and that's what we're here to help solve. We're not going to win all the time. Even if we are able to enable rail to take 10% of the trucking market, we've doubled the rail industry. That's how big this opportunity is. So we do very much want to be a solution and partner in providing that connectivity to some of these like inland ports, I'll call it, or warehousing districts that are just really, really hard for conventional rail to solve today.
And I don't know if you can, but can you talk a little bit about how this technology has been received so far by the railroads?
I would say very well. I mean, we're very public about the work we're doing with Genesee, Wyoming. That is not the only railroad in the U.S. we're working with right now. We're not ready to share who those other parties are, but this has been received very well. And also internationally. We're also active in Australia right now too.
Okay, it's good to hear. Now another question: how do manual switches get thrown for delivery of your vehicles?
Yeah, it's a good question. So, kind of coming back to like the CapEx, like there are going to be some cases where a manual switch is going to be a barrier, and we're going to have to look at electrifying that switch. But the endpoints, especially when the density is lower, it has been part of our financial analysis for the railroads. And part of the staffing is that you do have people at the endpoints, right? They're operating these reach stackers. The concept of operation is that person is on the phone. They're getting a phone call from the central management of this technology, and they're being requested to throw the switch. And then we can actually verify that switch has been thrown correctly through our onboard sensors and perception. But very, very, very focused again on making sure the economics make good sense. And it's not always going to make sense to do that.
Question for me, how many warehouses in the 8A area have rail access? So Kamal, it's a handful right now, but the good news is that there's a rail line that goes almost down the middle of all of that development. So yes, it would involve additional, obviously, infrastructure needs. But as far as bridging that gap between the rail line and the warehouses themselves, but I think speaking as we have on the demand and the volume being there, I think that would maybe be a good justification for that kind of an investment.
If you don't,
Do they,
Jacob, if you don't mind, if I could jump into it, we don't always have to have rail go directly to the warehouse. Like if we just bring in a warehousing district, then we have like an off-highway dray or just very productive dray. That's still a very, very big enabler for us. Rather than like 1 turn or 2 turns a day, we do 10 turns because we're in this warehouse district. That's also a big enabler here.
Yeah. So
Th-
I guess an example of that might be what, and Morris County actually owns several branch lines in the county, but they also operate a couple team track locations, where basically there's this kind of, I guess, similar concept where a bunch of stuff comes in and then it's kind of collected at that one location for more local distribution.
Jacob, I think we take one more question here and then we gotta move on here.
All right. Well, that's exactly what we have. We have one more question in the chat. Do you have any info as to how do short line operators see parallel operations?
I mean, the short answer is positively. Genesee, Wyoming is a short line conglomerate. They own multiple short lines. And they have a very positive reception to this because they were the first one that wanted to do something with us, and now they're very excited about it. A lot of short lines have an incredible amount of revenue concentration, and so they're highly motivated to diversify where their revenue is coming from to make sure these short lines stay operational.
Okay. So that was the last question.
All right.
Matt and Dan, thank you so much for a very interesting discussion.
Yeah. Once again, yeah. Thank you very much. Coming in from California like that, that's great. We appreciate it, and very interesting discussion.